All right, so today we get to learn or relearn the factoring techniques you learned last year plus some. So today is going to be quite the adventure. So we are doing multiple factoring techniques. The first factoring technique is what you learned last year, factoring quadratics. That's what you focused on last year. Typically you had problems that had 3 terms, but we also factored ones that had 2 terms, and we've talked about that already this year. But let's talk about ones that have leading coefficients, because that's not something that we have done too much of. So last year, most of you probably learned this method. So you find the factors of 6. So factors of 6, there's a couple of them. You could have 1 and 6 or 3 and 2. I'm going to try 3 and 2 first. It's kind of a little bit of a guess and check method. Then you find the factors of 12. There's also a multiple because you have 1 and 12, you have 2 and 6, and you have 3 and 4. And just guess on one of them. So I'm going to try 3 and 4. And what you do is you try to create a combination where when you subtract this number, this minus sign is telling us we're going to subtract them. When we subtract that combination, you should get the negative 1 that we have in this middle term. So when I say combine, I'm going to try multiplying this 2 by the 3 and then the 3 by the 4. So 2 times 3 is 6. 3 times 4 is 12. Well, if I subtract 6 from 12, I do not get negative 1. 12 minus 6 and 6 minus 12 do not give you negative 1. So I know this combination didn't work. So I'm going to try a different order. Let's try 4 and 3 that way. So 2 times 4 is 8. 3 times 3 is 9. And if I subtract it, so it's 8 minus 9, you do get the negative 1. So that means I found the correct combination. So what that tells me I'm going to do, I'm going to highlight where all these numbers are going. So that 3 is going to be with one of the x values. So both this 3 and that 2, they're essentially our x's. So 3 and 2x, we just put at the beginning. And then the 4 and the 3 will go on the end, but you've got to be careful where they go. So notice how the 3 was combined with the 3. We're going to end up multiplying them. That means when it comes to foiling, they need to be in opposite parentheses. And we have to get a negative 9, which means it has to be a negative 3. And then that means the 4 should go in the other one, so that way we get the 2 times 4. We're just doing backwards foiling. If you multiply everything out and actually FOIL it, you should get back to this original problem. So 3x times 3x, or 2x is 6x squared. You'll notice you get the negative 9x, positive 8x. That will give you negative 1x. And then 4 times negative 3 does give you, in fact, the negative 12. So always check your answers, even if it's just at least the middle terms. I should say the inner terms and the outside terms. Okay? So let's practice that again, that technique we learned last year. So once again, you find the factors of the first number. So in this case, 2 only has one pair of factors, so 1 and 2. 4 has a couple pairs, so let's try 2 and 2 first. And then we just multiply them out. So 2 times 2 is 4, 1 times 2 is 2. Remember, this minus sign right here tells me we're going to subtract them. So if I do 4 minus 2, I will never get a negative 7. 2 minus 4 will also not give me a negative 7. Now, since these are both the same number, there's not anything I can do to switch them. So I'm now going to switch over to 1 and 4 and try that combination. So 2 times 1 is 2. 1 times 4 is 4. We're at the same boat we were last time. So no matter how I subtract 2 and 4 together, you will not get negative 7. So let's try switching that order. So put the 4 first, then 1. 2 times 4 is 8. 1 times 1 is 1. And now we're in luck, because if I do 1 minus 8, so the 8's negative, you end up with negative 7. So that tells me, since we want a negative 8, that the 4 has to be negative, because 2 times negative 4. Just as a helpful hint when we put this in, and let's put everything in where it needs to go. So we'll put the 1 at the beginning, and we'll just put an x, so 1x. We'll also put the 2 at the beginning, so that's 2x. And then we've got the minus 4, so 2 times negative 4. Notice those have to be multiplied together. So the minus 4 should go in the opposite. and then 1 times 1, so we should put the plus 1 or positive 1 in the other parenthesis, and you're good to go. Okay, so hopefully that's coming back from last year. Let's try another one, just as a quick, refresher. So 3, only factors of 3 are 3 and 1. We're going to go to the 6. There's a couple pairs of factors. Let's try 2 and 3 first. And if that doesn't work, we'll use 1 and 6. And let's try it. So 3 times 3 is 9. 1 times 2 is 2. Once again, since this is a minus sign, we're going to be subtracting them. And you'll notice if I do 9 minus 2, I do get that positive 7. So, lucky us, we got the right combo the first time. I'm going to put the negative on that 2 so that we can get a negative 2 when we multiply. And then let's put it all in. So remember, these first two numbers tell you what the first number in each binomial will be. So we have 3x and just an x. And then the 3 has to be multiplied by the 3, so they have to be in opposite parentheses. So it's a positive 3, which means the negative 2 has to be the opposite from where the x is. And you've factored. All right, let's talk about some special quadratics, and then we're actually done with quadratics on this discussion. So some special quadratics out there are difference of perfect squares. So you'll notice it has to have a minus sign, and both your a and your b term have to be perfect squares. So there has to be a number that you can square to get there. So 49 is the same thing as 7 squared. 16 is the same as 4 squared. So we've talked about this already this year, but you would then factor this difference of perfect squares. 49x squared is the same thing as 7x times 7x. So that goes at the beginning. 16 is the same as 4 times 4. And since we need a negative 16, 1 should be negative, 1 should be positive, and you have factored. Let's talk about one other special kind of quadratic. The other one is noticeable. You'll notice both of these are perfect square ones. So there's the 2 terms perfect square. You can actually have a 3-term perfect square. You can factor it the same way you did it on the others. But often, not every time, but often if your first and your last term are perfect squares, it's going to be this technique. So 4x squared is the same thing as 2x times 2x. 9 is 3 times 3. If you'll notice, if I multiply that 2 times that 3, you get 6x, and you're going to be doing that twice, right? Well, 6 plus 6 does give me 12. I do need it to be a negative 12, and we haven't talked about this yet. But this tells me, that sign tells me I need to be adding these numbers together. But because the middle term is negative, that means that both of my values should be negative. So a negative 6 plus negative 6 gives me negative 12. And you'll notice you have the exact same combination for both. So you have 2x minus 3 times 2x minus 3. You can just write that as 2x minus 3 squared. So I went through that one a little fast, but that's because you can still use the technique we've already learned. If you recognize that there's a perfect squares at the beginning and the end of the polynomial, it makes it a little faster. So that would be factoring quadratics.